Okay, in this recording I'm going to introduce to you a particular type of variable which is called an integer. You'll be familiar with the integer from maths. It means any whole number, and it means the same thing in C programming, which is helpful. But to explain firstly what a variable is, as the name suggests, something that can vary in its value. So we use these variables in our C programming to hold a number that can change in value. If we use an integer variable, it can only change in value to some other whole number or integer value. This is quite useful, as you'll see. We'll do a simple program here in a moment, just to make it clear exactly what a very simple use of it. But what you need to know first of all is that within a C program, when we create a variable, that takes up some amount of space on our computer, and it takes up that space somewhere in RAM. Now specifically, and again it's for a more detailed lecture at some point, it will take up space on what is called the stack. In most cases, in your simple C programs, you don't really need to worry about where it's created it. A lot of the C program we'll be doing in this first half of the year or more will all be for the PC. And on a PC we generally have lots and lots of memory, even though we complain about not having enough when certain programs don't run. However, when it comes to dealing with embedded systems, one of the differences between that and writing a program for a PC is that you have very little resources available to you. So you've got very little RAM, you've got very little ROM, and you often don't have a huge amount of processor power. And that's all to save costs in order to make some small device. In cases like that, you need to know something about the different types of variables that you use, how much space they take up, and whether it's appropriate to be using that type of variable. So, to get started, I will open my C programming software and start a new file. Again, just like all others, I'm going to make my standard C file with hash include stdio.h, int main void, and so on. I'm going to pause the video while I write that so that it's not taking up your time. Okay, so there I have that section of the program written, and we're now going to look at introducing some variables. To introduce an integer variable, we need to use a keyword called int. Now, you'll notice as soon as I type int, it goes into a dark or a bold print. Okay, that's because this is a keyword, and the C programming environment here recognizes it as a keyword. There are actually only 32 keywords in C, so in matter of fact it's a very, very small language from that point of view. Now, when you create a variable, you should give it an appropriate name. Because this is very much an introductory lecture to the variables themselves, the name we give it here will just be num1. If you were, let's say for example, dealing with some information that you were counting, like counting a number of items, you might call that int count. Okay. If you were dealing with the height of a building, you might call that int height, or int height of building. In doing so, you make it very clear to people what that variable does. As I said, in this case we're really dealing with the very fundamentals of it, so there is no appropriate name to give it. Sometimes people have a tendency to say things like int x, and that's what you would do in mathematics if you want to have a variable for something. But the trouble is, with larger programs, you start using x, y, z, and then you start using different letters, maybe k, l, m, and so on. And when anybody else comes to look at your program, it doesn't make any sense to them. They don't know what those variables are doing. So always better if you can give it an appropriate name to the action that it's carrying out. So what have I done in this case? Well, I've given it a name, num1. I could call it anything I want, but I'm giving it a name, num1, and I've said it's an integer variable. I've put a semicolon at the end. You'll have noticed, or you'll have picked up as I go along, that semicolons go at the end of every statement within C. There are some situations where we don't put it, but we have to replace it with something else, and we'll be seeing that much later on. Oftentimes, when you create a variable, you might want to inform other programmers or other people that are going to read it what they're for. So you can put in these things called comments. So I'm going to say something very simple, because again this is fundamental stuff. So this holds an integer. Okay. Now, if I put this slash asterisk here and a slash asterisk, or an asterisk slash in the other direction, or in the opposite order at this end, that causes the writing to go in a kind of italic format. And what that tells us is that the compiler, when it comes to that, will completely ignore it, and it won't try to actually execute that. Okay, so it's just a comment for anybody that's reading the program. Now, I'm going to create 3 of these variables, num2 and int num3. As I mentioned, each one of these takes up a little bit of space. How much space it takes up depends on the environment that we're in. On these PCs, as far as I know, it takes up 4 bytes. There's a way of actually testing that, and one of the programs that I'll be getting you to do as exercises in the next week or so, probably 2 weeks, will actually test how big these things are and how large of a number they can hold. So as far as I know, on these ones they actually hold 4 bytes, which, oh sorry, something's after coming on there in the background. Okay, sorry about that. I don't know whether that got picked up in your recording there, but something had hopped up on my screen from a previous recording and it just started running. Okay, so we have 3 numbers, and as I said, as far as I know, on this particular system they take up 4 bytes of space. So if you were dealing with an embedded system like the 8051, they would normally take up 2 bytes. But even 2 bytes is a huge amount of space on the 8051, so in many cases you may try and go another route in order to try and take up less space, particularly if you didn't need that much. Again, as I said, there's one of the exercises that I'm going to get you to do in the next week or 2 that informs you a little bit more about what these variables can hold and what they can't, what are their limitations. Okay, but we'll be coming back to that later. So we have 3 integers, and I'm going to put numbers into them. So they're variables, so I can put whatever number I want into them. So number 1, I'm going to put the number 5 into it. Now, one thing I want you to try and get used to is actually saying what's written on your screen or when you're typing it. So this is num1 is assigned the number 5. Okay, so the variable num1 is assigned the value 5. Notice I didn't say equals. Okay, that is an equal sign that you would use in mathematics, but when it's used in C programming, it doesn't mean equals, and you shouldn't say equals when you're saying it in your head. It's assigned. So in other words, it's given the value, or it's loaded up with the value 5. Now, I'm going to put another number, number 2. I'm going to put the value 7 in there. Okay. Now, number 3, I'm going to do something slightly different with it. I'm going to say that it is assigned num1 plus num2. Okay, so remember, going back to our previous things, that our main function starts at the first opening brace. It'll execute this, which will ask the compiler effectively to give us some space or some memory for a variable called num1, and it's an integer variable, so it'll take up a certain size and it will hold certain types of numbers, mainly whole numbers. It'll also ask us to create num2, which again must give us another 4 bytes of space for that. Again, it'll hold integers, and then num3, the exact same thing. What we then do is we ask it to load the space or the memory that num1 is associated with. We want it to load it with the number 5. We want to load the number 7, or assign the value 7 into number 2. And then what we want to do is we want to add together num1 and num2, the values in those, add them together. That will result in a number. And if you look at it there, you can see that it will result in the number 12. 5 and 7 together will result in the number 12. So that all becomes equal to the number 12, and the value, or number 12, gets assigned to num3. So there's space there for it to go into. Now, I want you to have a think to yourself while I'm saving, because I haven't saved this file and I should have done. So what I'm going to do is I'm going to save that file. I want you to have a think to yourself, what is this program going to actually do? What's going to happen on the screen? So I'm going to call this, I'll just change to .c here so that I can see what ones I have. I'm going to call this simple integer. Okay. Now, many of you may think that we're going to in some way see the number 12 or something come up on the screen here. That's actually not what's going to happen. I'm going to click compile and run here. And you'll notice that all it says is press any key to continue, which, as we saw before, comes from this system pause function. So it didn't print the number 12, despite the fact we thought we had done that in the program. Now the reason for that is that the 12 has, I can assure you, gone into number 3. But the problem is that we haven't reported that in any way. In other words, the program knows that the number 12 is in there in num3. It knows that the number 5 is in num1 and the number 7 is in num2. But we haven't reported that. We haven't sent that information to the screen. If we want to send it to the screen, we have to use a library function from up here, which is stdio.h, standard input output. And if you recall, that was called the Printf function. Now, I did say in previous lectures that I'm going to explain the Printf function in detail. That'll be after I do another 2 or 3 of these, when you've got used to seeing the different types of them. So again, 1 or 2 things are going to get introduced here which won't be fully explained. Printf. And what I'm going to say is %d. Now the %d stands for, the d stands for decimal. I'm going to say num3. Okay. Now, without going into massive detail, what occurs is that when it sees this %sign, it checks the letter after it and it sees that it's a d, so it knows it's expecting an integer. Okay. It'd be nicer if the convention was to use the letter I there, and in fact you can on most compilers use the letter I, but the convention seems to be for a letter D. So the convention seems to be for a letter D, so I want you to get used to that because that seems to be what everybody else uses. Now, what will occur is that the value in num3 will then be taken from there and inserted in there instead. So I'm just going to run that quickly. And we see that the number 12 has come out. If I want to do several of these, I can say %d plus %d equals %d. And what I then have to do is put these in order that I want them to go in. I want num1 to go in the first place, I want num2 to go in the second place, and then num3 to go in the third position. So that's the first position, second position, and third position. We'll run that. And you can see 5 plus 7 equals 12. If I accidentally leave one of these out, like that one there, you can see that 5 plus 7 equals a very, very large number. Now what has occurred there is, this is looking for an integer, but I haven't told it what integer is to go in there, what variables to go in there. So it's picked the next place in memory, and whatever crazy number happens to be in there, that's what will go in. So again, I'm going to change that back to num3 and we'll see the correct output. Now, one of the exercises that you're asked to do is to try several different operators here, right? So arithmetic operators. So we've done the plus one here, but one of the ones, or the different ones we wanted to check out are the minus, the multiply, which is a star symbol, there's the divide symbol, and then there's another symbol there which looks like a percentage but doesn't do anything to do with a percentage at all. So one of the exercises that you're going to have to do is to try out each of those in a program very similar to this and see what they all do and see how they all operate. So that's one of the exercises that's open to you. What I will do down the line after you've done those exercises and submitted them is that I will do a quick recording where I will actually do those exercises as well and just explain to you what has happened in each case and why it has happened. Okay, but for the moment that just introduces you to the integer variable and how you create them.